In this section, we are going to work on some problems related to real numbers. So here in this particular question, we are given few numbers. We have to classify them into the groups they belong. So let's begin with the first number. We have -5. Now, the first question that I'm going to ask is this number a natural number? No, it's not a natural number because -5 is not a countable number. You cannot use your fingers to count a negative number. So it's not a natural number. Now, well, what about the next group? Does it belong to the group of numbers called whole numbers? No, it's not going to be whole numbers as well because negative numbers are not included in the group of whole numbers. Whole number is just an extension of the counting numbers with the number 0, so it's not a whole number as well. Now, then the next question, the next group that where it can belong to will be the group known as the integers. Now, we'll ask ourselves, is -5 an integer? That's true, it is an integer. That's because integers are numbers which consist of negative numbers, such as -1, -2, -3, -4, and -5, and so on. So this is an integer and it belongs to the group of integers. Then we move on to the next set of classification, which is a rational number. Now we know that a rational number is of the form P over Q, where Q is not equals to 0 and P and Q could be any integer. Now we ask if -5 is a rational number. You might say that it's not a rational number because it's not in the form of P over Q. But we can always rewrite -5 as -5 divided by 1. So that's always true. We can always divide any given number by 1, and now it gets converted into a rational number P over Q, where P is -5 and Q is 1. So that means this is also a rational number. Now, if it is a rational number, then it's not going to be an irrational number. So we can straight away reject the next group, which is a group of irrational numbers. Now, we can ask if it is a real number. Now, real number is a bigger set that may or may not contain the rest, such as the natural numbers. So what I mean to say, a real number is a bigger set. Let me write it down. A real number R is a bigger set that contains natural numbers, whole numbers, integers. We have rational numbers, irrational numbers, and these are all types of numbers that's included in the set of real numbers. Now, not necessarily if we are given a set, it has to contain all of them. So it could only contain integers, or what we can say, all integers are real numbers, all natural numbers are real numbers, all whole numbers are real numbers. So in our case, we have -5, which is an integer, or we can say it's a rational number, so that means it must be a real number. In fact, we can look at question number B and C, and we can say they are all real numbers. They are real. Now we go to the smaller, for the second part. It's a natural number? No, it's not a natural number because this is not countable. Similarly, it's not a whole number, and also it's not an integer. That's because it is in a fractional form. So it is a rational number. Now, the reason it's a rational number because it's given in the form of P over Q, where P we can consider it to be -13 and Q is a positive integer, which is +15. So this is a rational number. Now, since it's a rational number, there's no question of it being an irrational number. Now, the third question, okay, I missed square root here. So actually the question is square root of 6. So square root of 6, of course, it's a real number. The square root of 6, so whenever any number that involves a square root, and if the number within the square root is not a perfect square, then it's definitely going to be an irrational number. Meaning if I have given you instead of 6 the number 9, then the square root of 9 can be written as the square root of 3 squared. So 3 squared is 9, and 3 squared being a perfect square, so we'd get 3. So that means this is a natural number, or you can say this is a positive integer. So square root of 9 is actually not an irrational number, it's a integer. Whereas square root of 6, 6 being not a perfect square, so we will not get a decimal which will have terminating decimal values. So that means the decimal number square root of 6 will go on and on. It's a non-terminating decimal number, so it's an irrational number.